So, you're probably designing, let's say, an RC airplane all on your own, and you need to determine whether the plane will even fly at all. You realize that one of the four main forces is the lift force, and that determines whether your plane can actually fly. So you go on to find the lift equation. Let's use NASA, very trustworthy, and you get the lift equation. So you start analyzing. R so it's R's density. That's easy. That's just a density air. Your velocity squared, what you're flying, and your wing area. And you look at CL. What's CL? Well, that's a coefficient. And then you realize that it's determined experimentally. And there's two issues with it. Number one, you don't even have your plane built. How do you experiment something that doesn't exist? And number two, you probably don't have $1 million wind tunnel in your garage. Maybe let alone even your school if this is your school project. You probably have to go to your local. Not even most universities have a wind tunnel. You have to go to a large technical university, and that might be booked. So you think you're cooked. You don't. You can't even calculate whether your plane will fly. And the bright spot is there is. Meet the Polhamus formula. It is written by Edward C. Polhamus, a very famous NASA scientist, and it is used to estimate. It's not a guarantee that it's perfectly accurate, but a very nice estimate of your coefficient of lift, given that your plane flies under Mach 1. Well, I'm assuming that your RC airplane won't go past Mach 1, so I think this is very applicable. So it might look very complex, but it's not that really. Your focus here is 2 pi. AR just means your aspect ratio, and K is just a given constant. So if your aspect ratio is less than 4, use this. Aspect ratio is equal, greater than or equal 4, use this. So it might look very complicated, but there's no calculus involved. It's just aspect ratio, all of this. This, this is given parameters for if your Mach is less than 1. So what this gives you is CL alpha. This basically means is that the slope or the coefficient of lift given a change in alpha. And you can easily find the coefficient of lift itself by using CL alpha times your change in angle. But what happens if you're not the best at math? And plus, this calculation is very time consuming. Fear not, I've made a GitHub repository where I use Python to make a Polhamus equation calculator. So all you have to do is just input some basic variables, like your span, your chord, your alpha naught, which I'll explain later. And this is public, and I'll put this in the description, and you can download it. And it's very easy to run. You just go to online Python runner. Let's go this. And just, if you don't want to download it, you just copy and paste it. Copy, paste, boom. Let's run it. So let's say I want my wingspan is 500 millimeters. That's fine. And my wing chord is 100. That means I have an aspect ratio of 5. Our leading edge sweep is just how swept back your wings are. So it's the angle between your fuselage and the chord. Now I want to have a perfectly straight line, perfectly straight wing. It's high drag but high lift. So 0. And same with this half chord is at the half of the sweep angle. It's still perfectly straight, so 0. Now Mach number 0 for low speed. I'm not very fast. It's a park flyer. I'm certainly not making a Concorde, so it's 0. And so it just automatically calculates it for you. Super nice. So 0 left the angle attack. So minus 3.5. So I'm running clock 5. Clock I'll explain later. Angle of attack. So I'm flying at around 4. Around 3. Boom. It gives you a coefficient of lift. So just directly plug back into here. And you know your velocity, everything else. And you can nicely estimate how much lift your wing is going to generate. Well, how do you get your alpha naught though? Well, you go alpha naught is the angle of attack when your coefficient of lift is 0. So you find out by going to look at airfoil tools. So airfoiltools.com is a very good website for a lot of different airfoils. And so I'm using Clark Y, and it has already experimentally determined it for me. So my CL versus alpha, so it's 1 CL 0, so scale over here. And I'm following the yellow line because this is the 4 I'm using. 0, boom, boom. Around minus 3, minus 3.5. So this is how you get your alpha naught, by looking at a graph CL versus alpha and seeing what alpha is, what CL, the vertical axis, is 0. And so this is how you can estimate, I must emphasize that it's not completely accurate, but it is a very good estimate of a coefficient of lift without even doing much math. You're just inputting much because this code handles all the math for you.